All right, this is the last lesson of the week. It is called Finding an Indefinite Integral Using Substitution. An indefinite integral is one that's not linked between certain numbers. So it's basically like the general form of the antiderivative. Now, what we've been doing before is most of them we could turn into either a trig derivative and we could do the antiderivative of that, or ln derivative and we could do the antiderivative of that, or a power rule derivative and we did the antiderivative of that. But what happens if we don't have those set ones? Well, we would have to use substitution rule. Okay, so we're going to make them easier so that we can do the antiderivative of them using power rule or trig rules or whatever. But we have to make them simpler first. Okay, so this is one method that we can do integrals of, and then we're going to do integration by parts next week. And those are the only ones we do for Calc 1. There's many more, but those are the ones that we use in Calculus 1. So in university and in Calculus in high school. Okay, so finding an indefinite integral using substitution. Indefinite integrals that cannot be found using the integrals table in the previous lesson, that one that I gave you, sometimes can be found using the method of substitution. In the method of substitution, we use a change of variables to transform the integrand into an antiderivative that is in the table. So let's look at this, and you have to follow along. This is not a hard lesson, but I can lose you right off the bat, and I don't want to lose you, okay? So we're going to follow along closely. So for the example, to find the antiderivative, the integral of x squared plus 5 to the 3 times 2x dx. So what I would hint to you to do for substitution is most often it's what's in the bracket. And I'm going to label it as a u. So I'm going to substitute it in as a u. So I'm going to go u equals x squared plus 5. So that's my first step. Find the thing that's often in the most complicated piece. So I'm going to use what's in there. And I'm going to substitute it as a u. Now, what I have to do next, so my first step is find something to substitute as u. My second step is to take the derivative of that. So if I take the derivative of u, I get du. Okay, the derivative of u I write as du equals, what's the derivative of x squared? 2x plus 5 goes away. And then I took the derivative of x, so I go dx. So now I have du equals 2x dx. Now, before I can do the integral of this, I have to replace everything that's an x with a u at some point. Okay? So I know that x squared plus 5 is u. That's what I have here. U equals x squared plus 5. So I can rewrite this as, so messy. I can rewrite this as, that's not any better, but whatever. U to the 3, because over here I said u is x squared plus 5, so I can write as u to the 3, and then I can rewrite 2x dx as du. So I just did replacement. Now, are all my x's away? Yes. Do I only have u's? Yep. So what I can do now is I can actually just take the antiderivative of it now, because now it's just a power rule antiderivative. So I get equals, how to take the derivative of u cubed? Well, the u cubed will become u to the 4, or 1u to the 4, divided by 4. And what happens to the du when you take the antiderivative of it? The du has went away every single time we did that in the previous one. The du goes away because the du tells you it's a derivative. So the du goes away and it's replaced with a plus c. So now my answer is 1 over 4 u to the 4 plus c. And people will leave it here, but you can't, because the question actually doesn't have any u's in it. So your very last step is to replace that u back again now. So I can go 1 over 4. U is actually x squared plus 5, so I'm going to go x squared plus 5 to the 4 plus c. And now I have the antiderivative of it, and I'm done. Okay, all right, let's look at example A. Determine the integral of sine 3x plus 2 dx. So they're telling me I have the integral, so I have this, and I have the derivative of it. So the sine is not my issue, but this 3x plus 2 is my issue. So what am I going to do? I'm going to write that as my u. So u equals 3x plus 2. And say you pick the wrong u. Go back, try again. So if you pick the u, do the derivative of it, you try and replace, you can't replace everything, well then you pick the wrong u. Try again. So u equals 3x plus 2. And then my next step is to take the derivative of that. So the derivative of u is du. The derivative of 3x plus 2 is 3. The derivative of 3x is 3. Derivative of 2 is nothing. And then I have to put a dx behind it because I took the derivative of x. Okay. So I need to replace. So I'm going to get equal to sine of u. And now I need to replace dx. Wait, I don't have dx. I have 3 dx. So I need to get dx by itself. So how do I get dx by itself so I can replace it? Well, I'm going to divide by 3. So I have to do that first. Last time I didn't have to because I was replacing 2x dx. So I could just replace it with du. But this time I need to replace just a dx, not a 3 dx. So I have to move the 3 over. So I'm going to get 1/3 du equals dx. So now instead of a dx, I'm going to replace dx with 1/3 du. So I get 1/3 du back here. Well, that's way harder to take the derivative of. So what I'm going to do is I'm going to actually put the 1/3 in the front. 1/3 sine u du. And the cool thing is, if you just have a coefficient, the coefficient can actually come in front of the integral symbol. So you can go 1/3 sine u du. So now all we have to take the antiderivative of is sine u. Well, what's the antiderivative of sine u? Well, the derivative of cos x equals negative sine x. So negative sine x, the antiderivative is cos x. I don't want negative sine x, I want sine x. So then I can just rewrite it again. D over dx of negative cos x then would actually be sine x. So the antiderivative of sine x is negative cos x. So I'm going to get 1/3 negative cos x times negative cos x, or cos u in this case. And then the du goes away when I take the antiderivative of it, so I get a plus c at the back. Well, negative 1/3 times negative cos u, I can rewrite as negative 1/3 cos u plus c. And a lot of people will stop here. But remember, we can't leave it as a u because the original question has x's. So you have to replace this u back with 3x plus 2. So we're going to get negative 1/3 cos 3x plus 2 plus c. Okay, that's that one. B, I'm going to rewrite as x times x squared plus 1 to the half, because I always do that with radicals, dx. Now what's the complicated part? The x squared plus 1 in the half. So up here, I'm going to go over here, I'm going to go u equals x squared plus 1. And remember what I told you? If you pick the wrong u, you'll find out because you can't replace them all. That's totally fine. So then I'm going to get du equals, because I have to take the antiderivative, or the derivative of u. So I get du. The derivative of x squared is 2x. The derivative of 1 is nothing. And then I have to follow behind with the dx. Now I need to replace this with u. And then I need this to go away. So what I always do is I rewrite this so that it's easier for me to see my replacement. So I'm going to go x squared plus 1 to the half times at the back x dx. Now I can put them in any order because it's x times this times dx, right? So I'm going to rewrite it. So what do I need to do? I need to get rid of all these x's. I need to have u's in the end. So I'm going to have still the integral symbol because I haven't taken the antiderivative. So I'm going to get u to the half, and then I need x dx to go away. Well, I have 2x dx. So what do I have to do? I have to divide by 2. When I divide by 2, I get 1/2 du equals x dx. So I'm going to replace x dx with 1/2 du. So I'm going to get times 1/2 du. And then with the 1/2 in the middle, it looks weird. So I'm going to write my integral symbol, 1/2 u to the half du. And now it's in a form that I can actually take the antiderivative of. So what do? I write the 1/2, I write the u, I raise the half by 1, so a half plus 1 is a half plus 2 over 2, so I get 3 over 2. And then I have to divide by 3 over 2. And then the du turns to a plus c. Now that's the same as writing, dividing by 3 over 2, I'm going to multiply by 2 over 3 instead, times the half. U to the 3 over 2 plus c. The 2's cancel, so I'm actually left with 1/3 u to the 3/2 plus c. But I can't keep it with the u, I have to replace the u. So I'm going to get 1/3. U is actually x squared plus 1. To the 3/2 plus c. And then I'm going to look at c. C is e to the square root x over square root x. So I'm going to try u as square root of x. And the reason why is I know if I can get the derivative of e to this u, the antiderivative of that is e to the u. So that's easy. So if I have e to the anything, what I actually make u be is its exponent. So I'm going to make u be square root x, which means u equals x to the half. And then what do I have to do? Take the derivative of it. So u, the derivative of u is du. The derivative of x to the half is 1/2 x, 1/2 x to the negative a half dx, which is actually the same as saying du equals 1/2, and x to the negative a half is actually the same as multiplying by 1 over square root x, because that'd be x to the positive half, right? So this is just the same as that, dx. Okay, so let's look. What do we have here? I can rewrite this as e to the square root x, and instead of writing the square root x on the bottom, I can multiply by 1 over square root x dx. Right? Okay, let's see if we can replace. So I'm going to get still the integral symbol because I'm taking the antiderivative of it. So I'm going to get e to the u, because the square root of x is u. And then I need to replace this with u's. So I can replace this. So I can't replace the 1/2 times that. I can just replace this. So I need to get rid of the half. How do I get rid of half? I'm going to multiply by 2. So now I actually have 2 du equals 1 over square root x dx. So I'm going to replace 1 over square root x with 2 du. So times 2 du. Let me go like this so they doesn't get messed up. This looks like this. Okay? All right. So I'm going to rewrite this in a form that's easy for me. So I go 2 e to the u du. And when I have just something this simple, I can pull the 2 out of the integral symbol because it's just a coefficient. And I can do the antiderivative, or the integral of eu du. So the 2 stays at 2. The derivative of e to the u is e to the u. The du goes away then, and I get plus c. So I took the antiderivative of e to the u d to the u. E to the u du is e to the u plus c. And then I need to replace that u. So I'm going to get 2 e to the square root x, because that's what u is, plus c. D. I have 5x squared dx over 4x cubed minus 1. Well, the 4x cubed looks the most complicated. 4x cubed minus 1, so I'm going to try that. So I'm going to go u equals 4x cubed plus 1. And then I always take the derivative of that. So I'm going to get du. Ooh, that doesn't look good. Du equals 12x squared dx. Now remember, I need to replace every x out of here. So what would I have? I would have a u in the bottom. X squared dx I need to replace. Well, I have 12x squared dx. So I have to divide that 12 over. Dividing by 12 is like multiplying by a 12th. So I'm going to put a 12th in front. So now I have 1/12 du equals x squared dx. So I can actually take this x squared dx here and replace it with 1/12 du. However, the 5 doesn't get replaced, so the 5 is still there. So I'm going to get 5 times 1/12 du. So I actually get 5 over 12 du over u. Right? So that's the same as saying 5 over 12 times 1 over u du. Right? You can bring the 5 over 12 out. 1 over u du. Now, what's the derivative of 1 over u, or 1 over x, or the antiderivative of 1 over u, or 1 over x? Remember, it's ln. So I'm going to get 5 over 12. The derivative of 1 over u is ln absolute value of u plus c. And the du goes away and it gets replaced with a plus c. And then I have to replace my u, so I get 5 over 12 ln absolute value of 4x cubed plus 1 plus c. Two more. So now I have e to the x plus 4. What's the complicated part? Well, the x isn't an issue. So back here I told you whenever you have an e, you take whatever the exponent is and make it a u, right? That's what I told you here, if it's not just an x. But my e here is to the exponent x, so that wouldn't be helpful. So in this case, I'm going to make u be ex plus 4, because I know the derivative of ex plus 4 is just ex. And I need the ex to go away and the dx, remember? So I'm going to go u equals ex plus 4. Ooh, that's not pretty. I have to do the derivative of that. The derivative of e to the x is e to the x. And the plus 4 goes away, and then I have to write dx behind it. Now I try and replace. So I'm going to get the derivative of e to the x plus 4 is replaced with u. And then I need e to the x dx to go away. I need e to the x times dx to go to the way. Well, e to the x dx is du. So I'm going to be left with a 1 up here and a du beside it. Well, what's the derivative of 1 over u? The derivative of 1 over u, or the antiderivative. Sorry, I keep saying derivative because I'm so used to it. The antiderivative of 1 over u is ln x, or ln u. Ln absolute value of u. And then the du goes away when you take the antiderivative and you get a plus c. So I'm going to get ln is ln, remember? Ln absolute value of u, which is e to the x plus 4, plus c. And we know we're right. Why? Because when we take the derivative of a ln, we rewrite ex plus 4 on the bottom and the derivative of ex plus 4 on top, which is ex over ex plus 4. So if you look at e is actually the derivative of ln e to the x plus 4. So we can check and we can see, and it's right. Okay? F is our last one. What's the complicated part? The part that's underneath. So I'm going to get u equals 4 plus x squared. Then I take the derivative of that. U, the derivative of u is du. The derivative of 4 is nothing. The derivative of x squared is 2x dx. And I'm going to rewrite this so that the square root comes first. And then it's times x dx at the back, just so you can see what we need to also replace. And I can write them in any order because they're all multiplied. So I'm going to get the integral of the square root of u, and then x dx is right here. Well, I can't replace x dx with du because it's 2x dx. So what do I need to do first? Divide that 2 over. Dividing by 2 is like multiplying by half. So I get 1/2 du equals x dx. And now I can replace x dx right here with 1/2 du. So I'm going to times by, if it lets me. Come on, iPad. Times, oh, I want to work. Times 1/2 du. Now I can bring 1/2 to the front because it looks silly being in the middle. So I get 1/2. Square root of u is u to the half du. Remember, if I have a coefficient, I can bring it outside of the radicand, or the, oh my goodness, outside of the integral symbol. And I get u to the half du inside. And then I can take the antiderivative of that. So I get 1/2. The antiderivative of u to the half, I raise it so it has a 1 in front of it, technically. I go 1/2 plus 1, which is 3/2. And then I'm going to divide by 3/2. The du goes away and I get a plus c. So I get 1/2. And instead of dividing by 3/2, I can multiply by 2/3. U to the 3/2 plus c. The 2's cancel because they're across from each other, so I get 1/3 u to the 3/2 plus c, and then I need to replace the u. So I actually get 1/3 u is 4 plus x squared to the 3/2 plus c. So a little recap. When I have a trig one, I always make my u be what's in the bracket beside a trig. Oops. If I have an e1 and it's not to the power of x, my u is whatever the heck the exponent is. If I have a radical, it's what's underneath the radical, usually is my u. And you can just play around with it. If it doesn't replace all your x's, then you know you didn't pick the right thing. That is all for u substitution or determining integrals and indefinite integrals when you can't just do power rule or your lawn rules, okay? The key thing also, please remember that if you're given the derivative of 1 over x or 1 over u, if that's your derivative, the antiderivative of that is always ln absolute value x. Remember? So please, please, please remember that if you are raising it to the power of -1 and you add 1 to it and you get an exponent of 0 and dividing by 0, that is wrong, that you need to write ln absolute value x. Have a great day. I hope you have a wonderful day, whichever day you're watching this. And if you're watching it with the other podcast, have a doubly wonderful day. Talk to you guys soon.